Okay. Then you have string methods. Python out of the box gives you lots of string methods that can be used for processing the string, and we have seen few but very important ones. For example, the join, the replace, the split. Then you have this strip and capitalize and many more. So these are the ones, something very handy, especially for the data science. When you have the data which is strings, you might want to use them to manipulate, and then we would use these. Now we talked about NumPy library. NumPy arrays gives you more options compared to the list of Python, and we are going to use array for NumPy array and list for Python list. So list object and array objects will be different things altogether. One of the difference that you found that we have seen in the NumPy n-dimensional arrays, or let us focus on two-dimensional arrays, is that we use only one square bracket and a comma as a separator to index or to slice 2D, or a matrix in the NumPy array. Whereas in the list you need two brackets. Yes, in the list you need two brackets, but for the NumPy array you need one pair of brackets and comma separator, where the rows will be here and the columns index will be here. Now for the indexing, you could go with the traditional style, which is the start, or give the information of the end, or the steps. Okay, start, end, or steps. This is a traditional style. Or you can go with what have you seen in the last class, something maybe new. You can use lists. Okay, or even in continuation with that, you can use array as well. So list or array can be used. List of indices or array of indices can be used to do the slicing or to do the indexing, and you have now more powerful option. Now you can sort the arrays, one-dimensional arrays and two-dimensional arrays using the axis option. This will not work because you should have the same number. If you are using list on both sides, if you use list on one side, the other side will be automatic. But if you're using list on both sides, they have to have the same numbers. For example, let's say if you have a matrix here, let's say you have a matrix M, and then you are saying here, let's say 1, 2, then it should be like this, 3, 4. So what does it do? If you have list on both sides, it will catch the corresponding elements. Yani 1 with 3. So it will give you M13 and M24. Okay. So if you have list on both sides, a list of indices on both sides, this is how it will work. So you cannot have here 2 and 1. That might not work. Okay. So if you have list on both sides, be careful. It gives the corresponding element. It will not give you first, second column from here. Sorry, first, second row from here and third, fourth column from here. No, it will give you the corresponding elements. Okay. All right. Now we have seen the concept of copying array. If you have two arrays, A and B, if you say A equals B, then it will not copy an array. It will just make A refer to B. So it's like a reference. So if you change in A, B will also be changed. So to make an actual or true copy, you have to use a copy method, or there are other methods as well to copy. But I found this straightforward. You can reshape the arrays depending on your need. You can reshape the arrays depending on your need. You can break the arrays or join the arrays. For example, we have seen in the last class concatenation, horizontal and vertical stacks, and we also have seen split of 1D array and as well as 2D arrays. We have seen this in the last class. Then something very important that we have seen, vectorized operations. Can anybody tell me what do we know about the vectorized operations? Okay, Well, those are true. Yes, we can do the sum max, but I want yes. So vectorized operations means you are doing things for all the elements, okay, without for loop, without looping. For example, if let us say A is an array, if I say A plus 20, then it will add 20 to all the elements. Yes, we can do the operation to the all elements. So if I do A plus 20, 20 will be added to all the elements of A. Whereas if I have a list L, if I do L plus 20, it will not work. So that is the vectorized operations. That is the vectorized operations. Okay. Now, the vectorized operations are actually based on the concept of broadcasting. For example, if you have a matrix and an array, those broadcasting rules that we have seen in the last class can be used, and then you will do the corresponding operations. Not only plus, you could have many operations, plus, minus, or any other operations. And to simplify, the basic idea is this: when you have compatible array to the matrix, what is the meaning of compatible? The trailing, the dimensions from the right hand side. Yeah, if you have just 2 dimensions, then either the column should match. Okay, but if you have 3 dimensions, then you have maybe the last or the trailing dimension should match. But for 2 dimensions, we can just simply remember that if you have the columns match, if the columns match, then it will create a replica, or you can say duplicate copies, so that it matches the number of rows, and then you have the same this created matrix of the same size as the original one, and the corresponding elements will be added. If you want to have an operation for a specific row, you slice it. Instead of the matrix, you take the slice of the matrix. Okay. uh, let me show you an example. Okay, let me just clear this. Yeah, then no, you don't have to concatenate. No, no, you can do it like a slice. Let me show you. So let us create a random matrix. Let's say M as np dot random dot randint. Let us say the minimum value is 0, the maximum value is 10, and the size is 3 by 4. Okay, I think I missed a bracket there. Let us. What do you want? You want? Let me print matrix M first. What do you want? You want only these numbers to be multiplied by 10. Let us say. So what you can do is you can do like this. I will cache that row. Sorry, I'll cache that row, and I will do this operation. Okay. Of course, the numbers will change because we didn't set the seed. So let us set the seed. Let's say something. Okay. So let me print M before. So that was M before, and now you multiply it by 10, so you have 30, 10, 60, 10. Okay, is that clear?
Uh, Doctor, I
Yes.
forgot what does seed does. Does
A
it
seed,
generate
so
every
remember,
time?
yeah, so if you don't have the fixed seed, then whenever I execute the code, I will get different matrices all the time.
Oh,
So there
so
is no way to check, what did progress. So I could just, fix the seed, and then I repeat, and it will be the same random thing. So the random matrices will not change.
12 because you have 12 number, right?
No, 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 no. This is just a number, a seed. That is a seed. It's just
Oh,
a
it's a
number.
seed. Yeah, yeah, every seed has its own set of numbers. Yeah, okay.
Okay.
I think, right?
Yes. So whoever has the same seed will get the same random matrix.
Okay, okay. I understand now.
Okay.
Yeah, thank you.
Okay. So yeah, let's just do this. Yeah. So we have this broadcasting, and you know, you also have universal functions, or in short ufuncs. These functions, they are can be used for a scalar, or can be used for a one-dimensional matrix, or can be used for ND arrays. Okay, one-dimensional array or ND array. So these are many. There are many universal functions in NumPy. We just touched something very basic like sum, max, min. Actually, not sum, max. Yeah, sum, max, min, but also like absolute value and square root. And you have many more. Actually, there are lots of trigonometric functions and exponential like e power logarithms and those functions, and all of those are available in NumPy. Based on your need, you can use them. These functions are so flexible. You can use it for scalar or as well as for arrays. Then I think we, I'm not sure, did we cover masking? I think we started masking, but we didn't finish yet. Okay. So remember, when you have the slicing, you could have list or array of indices. You could also have a Boolean array or Boolean list that can be used for slicing. So what is the idea of this Boolean array? When you have an array, okay, you want to do element-wise comparison and see whether it satisfies a condition or not. For example, let's say if I say a less than 5, what it does is this operation creates a Boolean array. Where a is an array means, remember, whenever we say array, it means a NumPy array. Whenever we say list, it's a usual Python list. So for array, if you write a condition like this, it will do element-wise comparison. It will do element-wise check. And if first element satisfies this, it will write true. If the second element doesn't satisfy this, it will be a false. Similarly, for all the elements, you have an array containing true and false, a Boolean array. This Boolean array is nothing but a masked array. So for the array of the same size, let's say it has 10 elements, you will have 10 true or false. Whether it satisfies or not, based on that, you have true or false. This true or false array can be used for slicing, can be used for indexing. And the good thing is you could have a compound conditions. And I think this is where we stopped in the last class. So we'll continue from there. We'll see the compound statements and we'll finish this. So before we move this, do you have any questions, any comments, anything not clear in this? Any questions, any comments? All right. Now let us go to the masking. And we have seen we have seen this in the last class. When you have a NumPy array, you can use such conditions to get what we call as masked array. Okay. Can we do this for the list? No, we cannot do this for the list. You guys must have seen this from ICS 104. For example, here X is a list. Nothing from here will work. But when you have a NumPy array, you can see that you can do this. For example, for X less than or equal to 3, true, 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 and then all of these are false because they're not less than or equal to 3. So it's like element-wise comparison, but without for loop. If you had list, the only way to do this for the list is to do the loop, either using list comprehension or the usual way, but you have to use for loop. Here we don't need for loop. So this is a vectorized operation. Okay, and now if you want to get let's say only those elements, you could have done like this. Okay, so this is the array containing the element less than or equal to 3, and this is what we have. I think we stopped in the last class. Okay, now this thing you can this array of true or false, the masked array, you can save it in a new array like this, and you can use it. A good thing, or you can say the other flexibility that you can have is you can have compound conditions. For example, let's say you want to make sure that the element that you select from the list should be less, let's say less than or equal to 5, but should be also greater than or equal to 2. So I want 2, 3, 4, 5. I don't want 1 and 6. So I have two conditions, less than or equal to 5, and what's the other condition? Greater than or equal to 2. Yes. Now I will get two masked lists, right? This one will give you this one will give you another masked list. I want both of them to be satisfied. So whenever you have two sets of condition to be satisfied, how will you use? We combine them, and to combine you have two operators in Python. You have and or. Now if I use this and, it will not work. Why? Because this and is designed for scalar. So if I have a scalar here and a scalar here, what I mean is if I have a single true or false here, a single true or false here, then this and will work. But here, what do you have? You have a list of true or false. Here you have an array, actually not list, array. Here you have an array of true or false. So whenever you have arrays of true or false, and you want to do element wise, and the first element from this array compared with the first element, second element from here, second element, then you have to use this and. So to show that, let me have this, and also let us print the mask. Okay. We'll see war in a minute, Kumail. Not two, one, only one. The two is for MATLAB, okay, but one is here. So what it does is this, okay. So this and it will check this and this. Both of them are true. No, so this is false. Both of them are true. Then this is true. Both of them are true. This is true. Both of them are not true. So there is some typo here or what? There is this two should be okay. There is something here that is not correct. Ah, I see the error is here. That is something very bad, something no, silly. So it was here supposed to be three, not three, huh? Five, because we are comparing five with two, right? So now it will make sense. Okay, okay, yeah. So yeah, so you see true and true. So it's true, 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 true. One of them is false. It will be false. Okay, and what we get in the end is these elements, which are all true, and for that you have this. So you get 2, 3, 4, 5. 2, 3, 4, 5. Okay, so that is how and works. Okay, that is how the and, this and, okay, works. It's element wise comparison, and whenever we have element wise, it's the corresponding elements all the time. Okay, now let us see how or works. Yeah, that's what we're going to see, how or works. So let us say you want either it should be less than 5 or greater than or equal to 2. So get, well, the conditions, yeah, we can do or, but I want to come up with something meaningful. So let us see, how about this? It should be either less than or equal to 2 or greater than or equal to 5. Okay, because I want, if I use this with or, see, this is how you use or, by the way. If I use this with or, I will get everything. Okay, yeah, it will print all the numbers. That's right, Kumail. So to show that difference, let us make a new one. Let's say x less than or equal to 2. Okay, less than or equal to 2 or greater than or equal to 5. Okay, so that will be the case, and then we can say here greater than or equal to 5 and less than or equal to 2. We don't need all of this, actually, it's just confusing. Okay, so now we have that. Okay, and again we can do the same analysis. What is the meaning of or? One of them should be true. So here you have true, here you have true, here you have true, here you have true. No true, no, the final one is false. No true, it's false. Okay, and here you have a true, here you have a true. So you see 1, 2, 5, 6. So this is the or. Okay, So that is how we have or and now you can use the combination of or and compounding like this. So now these two are in one group, and you could say sorry, and another condition, uh, for example, whatever condition, and you could have very complex conditional statements. And remember, there is no loop required here. That's the best part. It is all vectorized. These all are vectorized. And the moment you have mask, again, you don't have to call it mask. For example, I could have just copied this from there here directly. I don't have to have mask like something. Okay, I don't have to have this. It will give me the same result. Yes, you can use the not operator as well. So let us see. Here, let us say, and uh, we can use all the conditional operators, okay, not equal to 2. So you're getting 2, this 2 will be kicked out because you say this and should not be equal to 2. Okay, and then let me use a mask here. Or I can copy all of this, but just something. So 2 is gone. See? Okay. So we can have uh, compound statements, and you can create the mask, and you can use it for slicing. And we will use this a lot. Actually, this is the one that we use a lot, and this is something in the data science very common. You have to select specific records, specific data based on some conditions. Then we will be using such style, because from here onwards, NumPy is our basis, and see, X is a NumPy array to begin with. If it is not NumPy array, this operation is not valid. If it is a list, you cannot do this. For list, you cannot do this. And that's it. So if you have a NumPy array, or you see the data science later on, you have another libraries which are based on NumPy array, you can do these operations. Okay. Any doubts, any questions? Any doubts, any questions? All right. Now we move to the last topic of this chapter, which is lambda and map functions. To show the lambda and map functions, I will take a very simple example, the same in the slides. And sometimes you have, for example, some simple functions that you create in Python that actually don't need a special name. For example, you have such simple functions, okay? And
One half.
sorry?
It's x to the power of 1/2.
You want to have 1/2, x to the power 1/2, but here I'm just making square.
Okay, sorry, I thought it was square root.
No, no, I'm just making square, okay? So here you see that you just create a simple function and you can use it like this. Now, this function has just one expression. For one expression, creating a function is not that good idea, not that efficient, okay? So Python gives you a very flexible way. It says you can create a function by keyword lambda. And these functions, they don't have a name. For example, this function has a name, sqr. But lambda functions, they don't have a name. That's why they're called as lambda functions. They don't have a name. The functions will have input, if you have more than one input separated by comma or just one input. And then you have a colon. After the colon, you will have the expression that it must return. For example, I'm imitating this same function. So that is the expression it was returning. So that is a lambda function corresponding to this function. Lambda function corresponding to this function. I could use this function as is, or I could save it by a name. Okay, and then I could, for example, let me copy this from here. And this is plot 2, 2, and then you see both of them will give the same result. I don't, again, if I give it a name, I'm doing something the same, right? I'm replicating this. So I don't have to give the name here. What I can do is this lambda function, I can use it like a expression here. See, these two pair of brackets, just to make sure that things are not, brackets sometimes are used not only for tuples, but to, group the things like we did for the, compound conditions. So group the things. So the first one is the lambda function. The second one is the argument. Okay, and you get the same idea. So instead of defining a function with a name that has a dedicated name, the moment you have a name, it will take some space in the system. Of course, there's a variable name or a function name. It will be reserving some memory. But these ones, they will not reserve any memory. They are the functions that are created then and there, and then are disposed. They will not be stored. Okay. But this function, it will be stored until you refresh or clear it.
Uh,
So that is something nice about lambda functions. Yes,
uh,
Faisal?
uh, it means this is faster, right? In terms of
Yeah, it is faster, and it is very handy. And in data science, when we will move to the fourth, I believe, or fifth topics, we'll see lambda functions are used a lot. Okay, lambda functions will be used a lot. Lambda functions can have more than one inputs. Here, there's only one input, but you can have more than one input. For example, you could have x, y, let's say, and then you have, like, let's say, x squared plus y. Then in the inputs, you give 3 and let's say 1. So now it should get 9 plus 1, 10. Okay. So you could have multiple inputs, but the main requirement of lambda function is it should have a single expression. Okay. It can return single expression only. You cannot have here multiple expressions. No, only one expression. So that is why writing the program in a compact form is so important. Instead of using the temp variable, if you write everything in a single expression, like a single line, then that single line can be written here. And that is why we stress in this course, at least, to write the things in as compact as possible, because you can use them in the lambda functions, and it will be very efficient. The code will be very efficient. So any doubts, any questions about the lambda function? Any doubts, any questions? Okay, good. So here is another example of lambda function. Here we have a lambda function here, and then the corresponding inputs. Here we have 3 inputs, x, y, z, and that is the expression that is returned by the lambda function. Okay, 5, 6, 2. That's the expression that is returned. Okay. So that's the idea of the lambda function. Now, lambda functions are very powerful. They will be used a lot. If you see any coded example, at least for the data science, you will see these lambda functions popping up here and there. But one thing, if you are using, again, lambda and the other one, map, that we're discussing, these two are part of the Python. They are not from NumPy. Okay, these are part, by default, Python has this. So let us say you have a list of numbers for which you want to get the squares. Then how to do that? Well, how about this? What do you think will happen if I do this? Throw an error. It will say this is created for a scalar. How can you give, or you cannot give a list? Okay, it should be an integer should be passed. So if you have a function that is created for a scalar and you want to execute it for the entire list, then you can use the map function. So map function takes a scalar function, that takes scalar input, and execute it for all the list. Instead of creating that for loop, and the other way is what, to create a for loop, and for each element in the list, you get the square of that, right? But you can use that map, and then what it does is it takes each element here and execute this function. And if you want to get the result out of it, you could say list. Okay? Yeah, by default, the map will return the map object like zip, it will return the map object. For example, if you give it, it's a map object, but you can get the list out of it. Okay, you can get a list out of it like this. Yeah, element wise. Okay, so you get the list element wise in the same order. So 1 square, 2 square, 3 square, 4 square, and 5 square, all of them the same order. So you can do that, and you can get the list. Yes, that's the next step that we were going. Okay, so now sometimes, like some simple things like this, we don't need so the entire function, so we can use the lambda. So here I could use lambda function instead of the function itself. Okay, and I will get the same result. So map and lambda, if you are not using numpy, then map and lambda together can help you in executing a lot of things. Okay, and then with the numpy, and also with the big data thing, but that of course we will not go that deep in big data, but yes, in big data, map, lambda, and map and reduce, they are heavily used. Okay, map function is heavily used, and well, that map is slightly different, so just forget about big data. But this map function is used typically in most of the places, but lambda function is much more popular. Okay, so that is how we use lambda and map. If you have numpy array, I don't let me show you something. Okay, so let's say, so what is happening here? Just to show you, this is, yes, so numpy, not universal functions, but numpy array has this inbuilt that it does vectorized operations, right? Vectorized operations. So if you have anything that is created for a scalar, then you can execute it for the numpy array. And this is actually the part of the universal functions. You can create the functions. And numpy has universal functions, no doubt, but you can create such universal functions and can use the numpy array. Okay, like vectorize. Yeah, vectorized operations, broadcasting, and universal functions, they are all related. Okay, but this is something that I wanted to show you, so that you see that if you have a numpy array, maybe that map thing might not be useful. Okay, that's why I was highlighting that if you are not using numpy array, then maybe map power will show. But lambda, yes, lambda for sure is a good thing. Okay, lambda for sure is going to be useful. That is how, let me just comment this. So that's how the lambda function can work. But map is still useful. Actually here, because we are using only the list, I cannot show you the power of map functions. But map can be used for anything that is iterable. Okay, map can be used for things apart from the list. And that's where the map will show its power. Okay, so map and lambda, they are very useful concepts. I would say lambda for data science, for our course, lambda is very much more useful or much more repetitive than map, but both of them are useful. Okay, both of them are used. Here is an example where you have two lists. You are mapping, you're using the map function over the two lists. So I created a lambda function of two variables, x and y, and then x is coming from list 1, y is coming from list 2. So it's all pairwise. So 1 and 5, 2, 5, 3, 3, 4, 5, 5, 5. That's how they will go. The order matters. So if you say x, y, x will correspond to the first one, list 1, y corresponds to the second one, list 2. To show the order matters, I have two codes for you. it's list 1 followed by list 2. Here is the reverse, list 2 followed by list 1, and you can see that both of them gives you different results, which makes sense. Okay, this is list 1 minus 2, and the other one is 2 minus 1. Okay, so that is all what we have in this chapter, in this topic. Do you have any questions, any comments, anything that wasn't clear? Yes, Kumail, go ahead. No,
Doctor,
no,
what about
now I
now?
can hear. Now it
Yes,
is
I looked
very
up.
low. The volume is very low.
Yeah, it seems that I have some problems in my mic.
Okay. Now I can see. Now I can hear clearly. Go ahead.
I looked up on the book and I didn't see the subjects that we've taken till now.
Yes, this
Uh,
Python review is new. No, maybe at the beginning of the course, maybe I didn't stress this, but the Python review is a new thing. Okay, this is
Even the
something new.
NumPy
It wasn't there
method.
before, but what we realized is, yeah, I will upload the final slides, but the current slides are available on the Blackboard, right? You can see them or not? Yeah. When once I hear from instructors, once I get the input from the instructors, I will update the final slides. Okay. And now to make sure that where the material is coming from, always in the last cell of the slides, I have included these references. Okay. In the references you can see, so the textbooks is not mentioned here, so it is not coming from the book. Okay, so that's true, it is not coming from the book. This is something extra. We added this because in the last semester we realized, actually we didn't knew this from before, but during the semester we realized that all these topics were not taught in 104. Okay, so we thought to have this extra chapter at the beginning so that it will be easy for the rest of the course. So yes, it is these topics are not from the book, but please refer to these libraries, and also please remember to use the help function, because in the exam you will be allowed to use the help function. So make sure that you know how the help function works and how to read the information from there. Okay. While for the homeworks, for the quizzes, yes, you can go to these online libraries and get the information, but during the exam only help function will be available. Okay. Maybe okay, so yeah, any other questions? Okay,
Yes, I have a question.
yeah, go ahead.
The material
Go
for
ahead.
the quiz is Python and NumPy library. The quiz.
Yes. Okay, yeah, this entire chapter. We can have the quiz on Wednesday, but I discuss it in the other class as well. If you guys want to have it, in evening on Wednesday or Thursday or Saturday or even Sunday. Sunday I think is the max. We cannot exceed beyond that. So if that is the case, please you let me know. I believe there is some WhatsApp group. Section 1 and 3 guys can discuss, and you can, if you all agree, we can have it in the evening. Okay. I can create the poll, but no, I don't want to go with the majority, right? Uh, Sunday during the class is also fine. So we don't want to go with the majority. And but, if you guys like in the evening, or even if you can, if you push it, Sunday is fine. So Sunday during the class is also fine. Okay. So maybe in the next class we can see this. So think on this, and in the next class I will check with you guys. Okay. Think about this, and we'll discuss. All right. So now we are done with this chapter. We are going to go to the statistics. So that is the third topic. All right. So that's the third topic of our course, basic statistics. Statistics can be roughly thought about. I mean, the statistics that we are using can be roughly thought about like this. Given the data can you come up with the summary of the data? Okay. For example, you guys are familiar with, summarizing English text. If even the class lecture, let us say one of your friends missed the class, then he might ask you what was covered in the class. So you will not go word by word from the beginning of the class till the end, right? You will just convey in very short, he covered, or these are the topics that were covered. So you're trying to summarize. So something in that line, in those lines, we are trying to see when the data is given to you, how can we summarize it either by one number or few numbers or by a picture, and see the data. Because if you have, let's say, a bunch of data, just looking number by number, it might not show you what the information it contains. So we'd like to see that information by using some sort of summaries or by using some sort of plots. And that is the statistics we are looking, not the statistics as it has many things, but we are using that some part of the statistics, some basics of the statistics. Okay. And these are all the topics of this chapter. And let us start with the first bullet. Here we are looking at the differences between uh, data and information and the concept of variables. So data and information are related. We have discussed this, I believe, in the previous classes. Can anybody tell me what's the relation between data and information? Anybody in the class? Anybody in the class? Yeah. So information is not new. Data contains everything, and from there you extract, or from there you find the information. So data is like a raw material which you process to get the information, or data is like a mine where the information is hidden, and you dig into that to get the information. You always get information from the data. You can say this is like a raw information and this is processed data if you want. Okay. So when the data contains information, you have to analyze the data, and the data should be collected and stored and given to people. When the data is given, or when the data is stored, usually we use the help of variables, and those variables gives you the information of the data. And if you just have a bunch of numbers, for example, if I say like this, let's say 2.2, 3.5, 3.9, 1.2, can you tell me what is the meaning of this? What is this numbers? Anybody in the class, can you tell me what is the meaning of these numbers?
Nothing.
Yeah, so far that's the best answer, nothing. But how about if I add a small heading to this? Will this number make sense now?
Yes.
So these are GPAs, right? So that is the variables. Variables, they add meaning to the data. So when somebody is collecting the data, they give these variables that has some information, and that has some you can say history, some concept behind it, and these variables give meaning to the data. Okay, these variables give meaning to the data. So given that, we are going to see how to get the information, in this chapter. We are not going to go deep. What we are going to do is, given the information of the variables, we are going to see what is the type of the variables, what is the terminology that we can use for the variables, and then how can we use the summary statistics, getting some summaries from the data. If you have 1,000 data points, we can get the summary of them, maybe by one number or two numbers or three number summaries, and how we can get information from those summaries. We can also plot the data, and from there we can try to extract the information. So we are trying to build this path. Of course, in this chapter we cannot. The entire course is about building this path, right? Entire course is about extracting the information from the data. So we're trying to build this path, but in this chapter we're just going to show how to think in that direction, at least some we can say one step in that direction, and the actual one will start with the future topics. Okay, so by the end of this topic, by the end of this chapter, you should be able to tell some of the typical terminologies of the data science, especially the terminologies related with the data. And then you should be able to identify the data distributions and should be able to compare the data. So hopefully by the end of this chapter, every one of us will be able to do this. Now, tabular data. Data can come in many forms, many styles. You could have data in the form of videos, you could have data in the form of images, you could have data in the form of graphs, you could have the data in the form of networks, and so on and so forth. So you could have data in so many formats. In our course, we are going to look at the data which is in the tabular or flat format. Okay, that is the simple data that we're going to see. What is this tabular or flat form of data? It is like a matrix, like a two-dimensional array, how you can say, like a matrix. Can you hear me?
Yes, yes.
Okay, so I think okay. Naif, I think you have some issue then. Okay, all right. So yeah. So tabular data is a data which has some rows and columns. It's like a table. It has some rows and columns, and that is the data that we're going to look in this chapter to make things easy for us. But if you have any other type of data, like images, videos, any other type of data, it must be converted to tabular form for any useful analysis. Why? Because all the algorithms for data science, all the techniques of data science are built on the assumption that the data is tabular or in the flat form. Majority, I would say 99.99 instead of 100, because there could be one or two. But yeah, 99.99% of the algorithms of the data science techniques are based on the tabular or flat form of data. That's it. So if you have data in any other format, like in the next course COE 292, you must be seeing the images or the videos data. You should learn how to convert it into tabular form. Okay, even you see the text data, data coming from lots of text. So all those will be converted to tabular or the flat form. And once it's done, then you can use the methods. Okay, so it's very important to know what is this tabular or flat form of data. Tabular or flat form of data has a couple of things. It has, first of all, rows. It has columns, and it has column headers. Okay, column headings. For each column there is a heading. That's not the data, it's a heading of the for each column. Now, this should be the case all the time. The rows corresponds to records, okay, or observations. For example, this row, if I see, it corresponds to faculty name Ahmed. So this is the area of specialization for Ahmed. This is the experience in years of Ahmed. That's the information about Ahmed, whether he is international or not, and his international faculty or not. And this is the number of assignments for Ahmed. So all of this data is related to Ahmed. So this is one record. This is one observation. Similarly, pick any of the other rows, you'll see that it is one observation. All of this is related to Aqib. Okay, so you see this is one record or one observation. Now, if you look at the columns, if you look, so let me write it in a different color. So it is, for a record, you have same observation, same object or same observation. So let me write it same object. It could be in a person, it could be anything. Okay. If you look at the columns, Columns are what we call as the variables. Okay, yani you have 1, 2, 3, 4, 5, 5 variables, or you can say fields. By the way, all these different names, why they are coming? Because data science, like I said, people from different disciplines will jump, or people with different disciplines will have some relation with data science. So in different fields, different words are popular. So as a data scientist, you will be working with somebody in bank, somebody in hospital, somebody in a different place. So they have different words for these things. Conceptually, they mean the same, but when they use words, they will be different. So that's why we have different names. Some people like to call it variable, some people like to call it field, some people like to call it header, some people like to call it title. So you have different names, okay? And those are the columns. What is something about the columns? You see, if I, for example, if I pick this column, experience in years, all of them are, for example, if I pick 20, what does it mean? Integers, that's right. But what is the meaning of it? It's 20 years, right? This means 10 years. So all of them, they have the same meaning, okay? They have the same meaning, okay? So if you pick any column, they have the same meaning. Okay, or they are similar in type, okay? Same meaning. So that is the tabular data. It should be always in this format. Sometimes you might find the tabular data, but things are flipped. In the columns, you find the variables. In the rows, sorry, my bad. In the columns, you find the records. In the rows, you find the variables. Sometimes things are flipped. If that is the case, if you find such data and you are using for our course for analysis, immediately you do the transpose to fix this. Okay, to fix this, you do the transpose. And remember, this is the format, and please remember it very carefully. That for us, whenever we have tabular data, the rows, they represent the records. The columns, they represent the variable or fields. Okay, so rows always represent the records. Column represents the variables or fields. That's it. Always it should be in this format only. If you get a flipped format, you unflip it. Okay, is it clear? Any questions, any comments? Any questions, any comments? Okay, now let us look at the data. Here you see all of them are numbers, right? All of them in fact are integers, but you can say they are numbers, right? So such variables or such data is called as numerical data. Okay, such data is called as numerical data. Okay, numerical data. How about this? They are text, right? They are strings.
Yes.
Yeah. Now if you have strings that are without any more information, then such data is called as categorical. Categorical. Now here you also have some strings, right? So is it categorical? Yes, it is categorical because it is strings, this is categorical. But can you order them? And if I want to sort it, is there a way to say this is first, this is second? Is there a way to order them or sort them?
Yes.
Yes, high is high, that's the name, medium, and then low. So such special type of data, and it is for sure it is not numerical. Okay, it is not numerical, no doubt. But instead of just calling it categorical, in general, we can differentiate it, and we call this as ordinal data because it has order. It has order. It is ordinal data. It is ordinal data. Now look at this. Here you have yes, no, yes, no. Let us say This yes, no, it's a Boolean. Yes, that's right. So this Boolean can be represented by true, false, or ones and zeros. Okay,
Like
ones and
conditionals.
zeros. Okay, so this Boolean data. So let me just hide this text now. It looks like number, but is it numerical? Now, what do we mean by numerical is if you take the average, the mean, they have a meaning. For example, if I take the average of it, I know average experience of all the faculty members. Okay, but if I take the average of it, will it have a meaning?
Nope.
No. So such data that looks like numbers, but actually it is having some sort of categorical, information is called as nominal. Okay. Now, nominal data, in general, I'm speaking in general strictly, nominal and categorical are the same. Okay, many people take nominal and categorical as the same thing. But for us in our course, we are making it very, distinct by saying that if they are numbers which represent the category, then they are nominal data. Otherwise, it's categorical data. Why it is different? Because later on in the future data science topics, you will see that we treat the ordinal data in a different way. We treat the nominal data in a different way, and categorical data. Some of the algorithms they require nominal data, so all the categorical must be converted to nominal. Some of them requires all numerical. Then we have to change ordinal into numerical, nominal or categorical into numerical. So that's why we are having these four data types: numerical, categorical, nominal, ordinal. One would argue, and it is correct, that that ordinal and nominal is same as categorical. That's true. You can have numerical or non-numerical, which is categorical, but we can further differentiate the categorical to make things easy for us. And you can have ordinal, something that you can order, and nominal that looks like numbers, that look-wise looks like number, but it is actually categorical. So you have these different data types, these four data types. Any questions, any doubts? Any questions, any comments? Okay. So now we look at the sum of the terminologies. So that is the type of the data, and it's written here. All of them are written here. Now we look at the terminology. Now some of the variables, depending on the objective of the data science project, depending on the objective of your work in data science, some of those variables can be classified as, some of those variables can be classified as inputs. For example, let's say your objective is to use area of specialization, use experience in years, and use whether they are international faculty or not. Use this to assign the assignments. So then this will become inputs: input 1, input 2, input 3. So you are using these as your input to tell how much should be the assignment for the faculty. Should be high, medium, or low, let us say. So then these are inputs or independent variables, or you have so many names. But easy way to remember is these are inputs, that's it. And those different names, you can look at it. Again, why those different names? Because people from different fields in their disciplines, they had these different popular names, and they would like to connect those names to this. But for us, the easy way is to know that these are the input variables. Input in the sense this is what is given to us. If you want to do analysis, we have to take these three into consideration to talk about or to predict something else. And what you're trying to predict or trying to identify is the output variable. For example, you would like to know the assignments. So that is the output variable. Okay, that is the output variable. Some of the variables are there, but really you might not use them. If let us say you're not using the name of the faculty in calculating the assignment, then that is called as auxiliary variable. Auxiliary variable. So these are the three terminologies that you have for the variable types. You have input variables, you have output variables, and auxiliary variables. Is this clear? input, output, and auxiliary. Okay, so let us look at different names that you can find. Okay, different names that you can find. Input variables are here. Okay, input variables are here, but they are very popular because you're looking from the statistics point of view. In statistics, they are called as independent variable. Of course, independent variable the statisticians can go very deep. Math and stats guys, they are very, precise about things. So independent variable could mean many more deep things, but for us, no. Independent variables are nothing but the inputs, or if you have coming from computer science, it's called as attribute, or you're coming from control electrical, it's called as control variable. If you're coming from I think earth sciences and those guys, they call it explanatory or regressor. Predictor is another word for, I think, engineer. I'm not sure, but different fields have different names. So all these are different names for the same concept, for the same type, for the same terminology. Okay, which is input variable. For dependent variable, which is corresponding to the output variable or outcome, you have different terminologies as well. You have predicted, explain, target, response, label, and so on and so forth. But all of them means the output variable. Okay, all of these means the input variable. And then you have the auxiliary variable. Sometimes you have the information which is like a meta information that is there, but it might not be really helpful. It might not be really helpful in the analysis, and usually you remove them before the analysis. So those are called as auxiliary variables. Okay, auxiliary variables. Now here is an example. He's asking us to identify first of all what are all the variables, and then identify the field types. Field terminology and field types, sometimes they can be confusing, but let's be clear. Type is the type of data. When you say terminology, it means what is the input, output, and auxiliary. Okay, what I want. Okay, so here you have a data. Here you have student ID, score of the student in corresponding subject, and then the GPA of the student, and then whether he is honor or not, and the grade. Okay, so every row is for one student. This is for student 2508. Similarly, every column has a similar meaning. If I look at this, it means it's a grade of the student. If I look at this, that's a grade. So it's a tabular form that we need, that we require. Now, can you tell me how many variables you see here? How many total number of variables? How many total number of variables? 6, right? These are the 6 variables. Okay, student ID, score, subject, GPA, honor, and grade. These are all the variables. Now let us look at the types for this variable. Okay, student ID. What is the type of student ID? Well, see, we're not talking about terminology, right? We are not talking. When you say auxiliary, it means yes, it's true, it's auxiliary, but this is terminology. Okay, we don't want to know the terminology of it. We want to know just the type. So this is. It looks like numbers. Yes, that's right. If we take the average, now if I take the average of the student IDs, will it give me any information? No. So then this is nominal. Okay, this is nominal because the average or the mean will not have any information. It's not. It looks like number. It also has some meaning as this, but it is nominal. Okay, it is. How about this? How about score? So those are the scores. This is for sure numerical uh, because you can take the average score, you can min and max of the scores. Okay. We have the subject. Subject, it's categorical. When you have categorical, we also need to think whether it is ordinal or not. Can you sort them? Can you rank them based on some sort of importance? Like math should be first, then physics, then chemistry. Yeah. If you cannot sort them, then it is categorical. How about 4? This is numerical. How about 5? Okay. Yes, ordinal, because you can say honor may be better than not honor, so it is ordinal. Okay. You see, ordinal doesn't mean it is all always numbers. It could be no something that is well, here in this case you could say ordinal or nominal. Okay, you could say both. But yes, if you think you can order it, like honor student first, then the other one, yes. But otherwise, it could be also nominal. Okay. How about this grade? It is ordinal. Okay, ordinal. Okay. So you have all these data types. Let us see what we have here. Yeah, for honor it is used here as nominal. Why? Because that ordering where you say honor students before the not honor students may not be applicable all the time. That's why it is written here nominal. You have to, again, these are in, sorry, can you hear me now? Yeah, so these are some minor differences, but the main is this, that you can have numerical data and then everything is not numerical. That not numerical could have many varieties, and when you are actually using it for analysis, then you have to be very careful whether you are using it as like an ordinal data, nominal, or categorical, how you are converting it. But knowing that it is numerical and not numerical, that is the first step. Okay, that's the first step. So these are all the fields and the types. All right, so that is something about the data. Now let us see how to extract the information from the data. The first thing in extracting the information about the data is to draw some plots to picture the data, because uh, picture might reveal more information than looking at the numbers. So here is what first you can say step towards picturing the data. It's called as histogram. And to create histograms, we need frequency. Histogram is nothing but frequency distribution. Okay, so it's a graph that shows how many times each value occur in a variable. How many times each value occur in a variable. For example, if I want to look at the grade, how many times A is coming, how many times A plus is coming, how many times B plus is coming, how many times B is coming. If you have that information, you have frequency distribution, and this can be plotted, and that is called as histogram. So histogram is nothing but a graph of frequency distribution. What do you have in the histogram? Usually you have, typically it's not must, you could have x-axis, y-axis flipped, but usually on the x-axis you have the observations. Okay, you have the observation like a plus, or sorry, a plus a, b plus b. These are all the observations, and then the number of times the value is repeated will be shown by the, you can say uh, like a bar, like a box, okay, or like a bar, which is perpendicular to the x-axis, okay, which is perpendicular to the x-axis. And the height of the bar shows how many times the value has been repeated. For example, let us draw the histogram for the grade. So on the x-axis, you have the unique values. Sometimes those unique values could be sorted. For example, this is ordinal, so I know for some reason that A should be first, then A, then B plus, then B. So that is how the x-axis will be. The y-axis, you will have the bars. Okay, you will have the bars. For example, for A, how many times it's repeated? A plus, sorry, it's repeated one. So that is for A plus. How about for A? It's also only once. How about for B plus? You see 1, 2, 3, 4. So it should be 4 sizes of this. Okay, may not be exact, but that is the 4 times. And for B, it is only 1. Okay, so that is how the histogram of grade, or the frequency distribution of the grade column looks like. On the x-axis, you have the unique values. On the y-axis, you have perpendicular bars. These are the bars. Okay, and you can have the values 4 and then 1. Okay, So that is the histogram. So instead of looking at these, you can look at this picture, and this picture will give you lots of insights. Of course, here you have only few of the, but let's say you have 100 students. Then the picture, looking at the numbers will not get you much, but looking at the picture, you see, okay, there are too many students compared to the other with B plus score and things like that. Okay. Similarly, you can pick any column and do the histogram and draw the histogram. We'll continue with the histogram in the next class, and also we'll finalize the quiz. So in the next class, please let me know what is the preferable time. Should we take it in on Wednesday in class, or I prefer in the evenings, but again, you guys decide, and with the other section also you can discuss if you want on the WhatsApp group.